Okay, this is one of your homework questions from Module 3. In fact, it's question number 3 that a student asked, so I thought it'd be worthwhile to actually see this worked out. So they're asking you to construct a confidence interval of the population proportion. So as soon as I read that, I go, oh, I have a formula for that. So that's the formula. And we're given this information. So x equals 860, n equals 1200, and I want 94% confidence. So kind of in some steps here, the very first thing I probably would do is find p hat, because I see I need that in my formula. So p hat is the sample proportion, which is x over n. And in this case, 860 over 1200. So if you take 860 and divide by 1200 in your calculator that I'm doing right now, you should get 0.716666666, so we'll call it 0.717, since they asked us to round to 3 decimal places in the answer. All right, so that's p hat. I know what 1 minus p hat is, right? Because that would be 1 minus 0.717, which would be 2.83. So 1 minus 0.717, which would be 0.283. I know what n is. That's my sample size given, 1200. However, I don't know what z is. So the problem is they have these cheat tables that you can just go straight over here and find 94%. Uh-oh. So I have to understand how to get this z value from the z table based off of a confidence that's not in my little cheat sheet. No problem. So remember what you're doing here with this confidence is this middle area. So we'll just go like here and here. This middle area is your confidence. So that would be 0.94. Remember, the entire curve has to add to 1. So if I take 1 minus this value, 0.94, I get 0.06. However, there's 2 pieces here. So I need to divide that by 2 to put half of it there and the other half of it there, and I get 0.03. So if you take and you put these pieces in here and you add them up, you'll see that they actually add to 1, 0.03, 0.94, and 0.03. So what I need now are these z values. If you understand this curve is symmetric, sorry, that kind of went on my z there. This is the negative z value, and this will be the same number, but the positive. So the easiest thing to do is look within the table where the probabilities are, that's the 4-digit pieces, and try to find the value that is closest to 0.03. So I look around, and it looks like that would be the closest number to 0.03. So I read my z value, negative 1.88. So if I come back up here and I look at my drawing, that just says this would be negative 1.88, and that of course would be positive 1.88. Okay, I got everything I need for my actual formula. So let's do this. I'm going to have to scroll down. So remember where all these numbers are coming from. The 0, so I'm going to do 0.717 plus and minus my z-score, and then the square root of my standard deviation. So once again, in this case, it is 0.717. Let's do the lower bound. So this will be minus my z-score, 1.88. That's why this is the lower bound. It's the minus the z-score. And then times my standard deviation, which is my p hat, oops, and then times my 1 minus p, which we did above, which is 2.83, and then all divided by the sample size n, which was 1200. Okay, so that's it. We're just going to use calculator now, but just convince yourself where all these numbers came from. So the 0.717 was the x over n. Then I did the 1 minus that value, and then my n was the 1200. My critical value for my z was the 1.88. Now, what's good practice to do, and sometimes students actually have issues with plugging this in their calculator. So if you don't have one of them fancy smancy calculators, I probably would suggest doing this in steps, meaning I'm going to multiply the top first, and I get 0.202911 over 1200. Scroll down a little bit. And now I can take that number and divide by 1200 and square, oops, I'm doing stuff in my calculator I know you can't see, and then I square root that value. So when I do that, so I get I'm just bringing this stuff down, minus 1.88. I took the square root of 0.202911 divided by the 1200, and I get this value, 0.013. So the reason we kind of like to do that in steps is that's the standard deviation, what's in parentheses. If I do one more step and I take the 1.88 and I multiply it times that value, I get 0.02444 and a bunch of stuff. This is the margin of error. And you really like to do this in steps because now the upper bound will just be this value plus the margin of error. So I take 0.717, I subtract this 0.0244, I get 0.692, 0.692 for the lower. And so then the upper, since I found the margin of error, is just simply plus the margin of error. And so I take 0.717 and I add 0.024 and I get 0.741. So what you should do is you should go back up here to your graph so you understand what you're doing. We're basically making a confidence interval around this sample proportion, which was 0.717. And we got the low value to be 0.692 and the high value to be 7.41, which makes sense. This middle value, that's in the actual interval. So that's how you kind of know when you're doing these, if you're doing them correctly or not. But again, it's definitely nice to say, well, I mean, these are things that can be important later. This is the standard deviation. And then the next step, multiplying by that critical value, give you the margin of error, because remember, all of these problems is the sample plus or minus the margin of error. So hopefully that helps on how to read the table, because unfortunately, they can't give you every single confidence interval, right? And so you're going to have to understand how to actually read the table as well. Hope that helped.